Welcome to myprojectbazaar.com. The project title is Effective Extraction of Visual Event Related Pattern by Combining Template Matching with Ensemble Empirical Mode Decomposition. The project abstract is a novel approach by combining template matching with the Ensemble Empirical Mode Decomposition, that is EEMD. The EEMD technique is applied to decompose the noisy data corresponding to signal trail event related potential into the so-called intrinsic mode functions, that is IMFS. The effective extraction of event related pattern proposed in this paper relies on elimination of IMFS, which capture the features corresponding to artifacts and brain signal based on cross correlation with the suitable template extracted from the evoked potential obtained by a convolutional unrestricted averaging across a large number of trails. Our project flow diagram is to reduce the noise from EEG signal by using DWT. It means on discrete wavelet transform. First we have to collect the dataset. In the datasets are our related process. So with our EEG signal, it means electroencephalogram signal going to analyze the brain signal. According to the datasets, we have to read the input of our EEG signal. So after reading our input signal, we are going to remove the external noise to apply the some filtering methods. So next we have to apply the DWT of our input signal. It means discrete wavelet transform. After applying our DWT transform, we are going to apply the ICA. It means on independent component analysis. So after analysis the process, we are going to apply the IWT. It means inverse discrete wavelet transform. Next we have to extract the features by using on wavelet detection. So we are going to detect the corresponding wave to remove the external noise and get back the original signal. Finally we are measure the performance for accuracy and sensitivity and specificity. Our project source code file was run from the command window. In current folder shows some files. So our source code file was stored in main.m. So it is our source code file. So it is the mat file. In that mat files are our input signal of our datasets. So we have to run our main.m file. After run our program, they are going to choose our datasets. So it is the some signals are there, so we have to select any one of our input signal. So it is our input of our EEG signal. So after it is the input number of specific wavelets. So we are going to decompose our EEG signal. So we are going to give 1 as dB13, 2 as dB40, 3 as symbol of 13 and 4 is symbol 21. So we are choose any one of the number. So we are going to give the dB13. So give number as 1. So next we have to select some threshold. So in the threshold I will apply the 3. 3 means minimum and maximum. After thresholding we are going to threshold types. So which type we are going to apply, whether it is soft or hard. So I'm going to give the soft threshold. So I will give the number as 1. So after completing the process, the optimized features will be calculated. It is going to analyze our genetic algorithm. Is going to get back the best evaluation results of our genetic algorithm. So finally we are going to extract our input signal. So first we are going to get it is our EEG signal. After reading our input signal, we have to remove the artifacts of our input signal. So next we have to apply the three steps of trial response. So it is the three types of our trial response of our input signal. Then next we have to find the EEG true EEG signal for different approximation techniques. So it is the detection 1, it is detection 2, it is detection 3, and approximation and true EEG signal. So next we have to get back the denoised of our input signal. So it is approximation signal, it is denoised D3, it is denoised D2, it is denoised D1. So after getting our input signal, finally we are going to denoised for our input signal. So it is true EEG signal, it is our noisy signal. After noisy signal, we have to remove the denoised signal by using a DWT. So it is the noisy signal to varying the color formations. So we are easily identify the color bands of it, means calculated as frequency versus time. For it is true EEG signal, it is noisy signal, it is denoised EEG signal. So it is the genetic algorithm to get back the original of our best value to remove the noise. So it is a performance of each individual evaluation, it is generations, it is finally we are going to identify the noise of our best solution in the performance. So it is the best evaluation results shown on the graph. In X label shows the number of generation and Y label shows the maximum value to best solution. So finally we are extract our EEG signal. So it is 5 type of extraction we are going to apply. So first extraction we are going to some type of removing noise, and it is second, it is third, it is fourth, and finally we are going to getting fully noise removed signal. In command window shows the after SNR. So in command window shows the our DWT of error will be 7.6, and before SNR how many values will be get back, and after SNR how many values will be get back our SNR value, and number of evaluations and elapsing time will be shown on our command window. It is the overall process to remove the EEG signal to remove the noise. So the project demo was completed. Thanks for watching this video.